Alright, section 10.3, I'll take a look at 4 problems with you today. We're going to start by identifying whether this equation is an ellipse or a circle, finding the quote-unquote critical information. If it's a circle, we would be finding the center and the radius. If it is an ellipse, we would have to find the center, the vertices, the foci, and then sketch its graph. Same thing for this problem. This one's in standard form, this one's not, so we'll have to be able to get it into standard form and then do all the same things. Problem number 3, they're going to give you some random information and ask you to come up with the equation of the ellipse in standard form. So for this one, they're going to give us the vertices, and then they're going to tell us that it passes through some other point. And then the last one, again, same as the number 3 here, ask us for the standard form of equation of ellipse with, and this time it gives us the center. It tells us that A is equal to 3 times C, and then it's going to give us the foci. Alright, so let's go back and start on the first one. First thing it asks us to do is identify this equation as either a circle or ellipse, and that should be very quick and easy to do. If you have two squared terms, x squared, y squared, and they're both positive, or I guess they technically could both be negative depending on the equation, but let's just assume that they're both positive for now. That means that you are dealing with either a circle or ellipse. So when I look at that, because I see two squared terms, positive, implied to be positive, I know that that's either a circle or an ellipse. And if you have it written like this, where you have denominators, just look at them. If they're the same, it's a circle. If they're different, it's an ellipse. If it was written like this, then you would be looking at the numbers in front of the x squared and the y squared. The rest of that wouldn't make a difference. And same thing, if they're the same, it's a circle. If they're different, it's an ellipse. So for this particular one, I know it's an ellipse. And thankfully for us, it's in the standard form already. And if you don't remember what the standard form looks like, you'll either want to look in your book or check your notes to make sure that you have the right information. But since it is in standard form, the critical information, one thing I would want to know is what's its center. So the center would come from setting the quote-unquote parentheses. I don't actually see parentheses here, but this could be written as x minus 0 quantity squared and y minus 0 quantity squared. So the center is right at the origin. It's at 0, 0. Because it's an ellipse, remember that the bigger of these two denominators is the a squared number. So a squared is 8. That means a squared is 64. That means a is 8. And since 8 is under x, that means my ellipse is longer horizontally because it's under x. The bigger number was under y, it would be longer vertically. Alright, so why is that important? Well, if I kind of look at that, look back at our notes, the center is going to be here. Because it's longer horizontally, that means I'm going to move 8 to the right and to the left. And I really don't even need to know that it opens or that it's longer horizontally or vertically. Whatever the square root of that number is, look at the variable it's underneath. If it's x, that means it's going right and left that distance. If it's y, it would be going up and down that distance from the center. So the only reason I do need to know that this is a and it's the bigger number is because we consider the ones that are furthest away from the center, the vertices. So the vertices, which is something that they would ask for, is going to be from the center. Now I'm moving right 8 and left 8. So if I move to the right 8, I'd be adding to the x value, so it'd be 8, 0. Move to the left, I'd be subtracting 8 from the x value. There are my vertices. Now the square root of 28 is not necessarily a nice number or an integer, but if I took the square root of 28, probably would ask you to simplify. So I say it's 2 squared to 7. 7. That is how far up and down you would go. And remember, the book doesn't have any fancy name for them. I just called them the other vertices. They're not going to ask you for those, but you would need to know those in terms of the graphing. So in terms of critical information, when I say that, the book will actually have everything listed out that they want you to find. It's the center, the vertices, and then the other thing I want are the foci. And so to find the foci, I need to remember the little equation they gave us, and that was c squared is equal to a squared minus b squared. So for us, c squared is going to equal a squared is the bigger of the two denominator numbers, 64, minus b squared, which was 28. So I take 64 and I subtract 28, and it ends up giving me 36. And since a represents the distance from the center to the vertice, b represents the distance from the center to the quote other vertice, c represents the distance from the center to the foci. And remember that those are always on the major axis, or they go the same the directions the vertices do. So that means C is equal to plus or minus 6. So from the center again, you are going to add 6 to the x value and subtract it from the x value because the bigger number is under x. So my foci would be 6, 0, and negative 6, 0. There's all of my critical information. Now in terms of graphing it, if all they asked you to do was graph it, you don't even need to list off that critical information. You would end up finding it as you go through the steps to graph. Alright, so I would look at it and say, okay, I can quickly identify the centers at 0, 0. I usually just put an X there for the center. You can put a dot there. It doesn't matter. I take a look at the denominator, one of them. The square root of this number is 8. It's under x, so I would go 1, 2, 3, 4, 5, 6, 7, 8 to the right, put a point. 8 to the left, put a point. Look underneath y. That's going to give you the square root of 28. Now you're going to have to approximate this, so think in terms of your radical numbers. I know 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. It's got to be between 5 and 6, so I'm just going to approximate it to be 1, 2, 3, 4, 5. I'll just pretend like it's 5.5. 1, 2, 3, 4, 5. And now I've got my 4 points, and now I just basically draw my little oval shape or ellipse through this the best that you can. Try not to have a bunch of points, like try not to make it look like a kite, but I'll understand that you're drawing it by hand. So there's the sketch. I don't even necessarily need all that information. The foci in terms of the sketch, knowing exactly where they are, not overly important for the sketch. Alright, number 2. Same question. Difference is it's not in standard form. And so like I said, I can see that I have an x squared and a y squared. They're both positive, so I know it's a circle or ellipse. And then the numbers in front now are different instead of in the denominator. So I know that this is actually an ellipse. And so now all I have to do is get it to look like that. Well, how do I know if it's in standard form or not? Remember when we were dealing with the parabolas, if you've got an x squared, then hopefully when you look in that equation you don't see another x. I do. So that tells me that I'm going to have to complete the square of the x's. Take a look at the y's. You've got a y squared term. There's a y term. That means I'm also going to have to complete the square with the y's. I'm going to have to do it twice. And so I'm going to put the x terms together and say it's 6x squared plus 18x. And I'll look at just these by themselves. These y terms are still there, so I still have the 2y squared minus 10y, kind of group them together. Anything else I'm going to kick over to the right side. And then if you remembered what to do when you were completing the square for the parabola, it's basically the same thing. You just do it twice is all. Remember, you want the x squared term to have a 1 in front. This one clearly doesn't, so I'm going to factor out the 6 so that it looks something like this. And now, ignoring the 6, I can say, yep, there's a 1 in front there. Same thing with the y squared terms. I want there to be a 1 in front of that y squared term if I can, so I'm going to factor out the 2. And now, kind of treating these as 2 separate problems, I can now do that step where I take a look at the b value, divide it by 2, square it, add it to both sides. So I've got 6x squared plus 3x. Take half of that, that's 3 over 2, square it, that would give me 9 over 4. So I add that inside the parentheses. And then technically I have to catch that I'm not actually adding 9/4. I am in the parentheses. Technically I'm adding 6 times that. So over here it's really 6 times 9/4 that I need to add if I want to keep them balanced. Do the same thing with the y's. If you take half of the b value, that's going to give you 5 over 2. Think of it as a fraction. 5 over 2 squared, if I square them both, is going to give me 25/4. I'm adding it in parentheses. Technically I'm adding 2 times that. So it's 2 times 25/4. And now these should be perfect squares. I should be able to complete the square with them. So I have 6 times, remember there was a couple ways you could remember to do it. It was what number did you square? I squared 3 over 2, or just take half of the b value and put it in here. Pay attention to the sign. It's going to be x plus 3 over 2 squared. And if you FOILed that out, sure enough, that would give me 9 over 4 in the back. Same thing here. It's plus 2 times y minus 5 over 2, it's half of that number, squared, is equal to, now I just need to simplify this a little bit more. Again, I recommend that you simplify that and that before you get too far carried away. So I can take a 2 out of both of these. Looks like that's going to give me 18 halves. Take a 2 out of both of these. Looks like that's going to give me 25 halves. And of course you notice I waited on the negative 2 to see what the common denominator would be. Looks like it's over 2, so I'm going to change that to negative 4 halves. And so I've got 6 times the quantity of x plus 3 halves squared plus 2 times the quantity y minus 5 halves squared is equal to, if I add all these together, that gives me 14 or 39 over 2. And now because it's an ellipse, I do not want numbers in front here if I can avoid them. Sorry, take that back. Since it's an ellipse, I want this to equal 1. So I'm going to multiply everything by 2/39. And that will force the right side to equal 1, which is what I want it to do in standard form. If I distribute here, I'm going to have, again, if I can simplify the 6 and the 39, I would, but I can't. It's going to be 12 times the quantity x plus 3 over 2 squared over 39 plus 4 times the quantity y minus 5 over 2 squared over 39. And in terms of writing the answer in standard form, this is how it's written. How you might want to think of it if you have to graph it, like we're going to do here in a second, is you might want to think of it like this. It's x plus 3 over 2 quantity squared divided by, think about multiplying by the reciprocal. This is really that. Think if you multiplied by the reciprocal. The 12 would go up to the numerator, the 39 would go into the denominator. So this is how it should be written if the answer is the equation. If you're going to graph it, however, you might want to think of it like this. And the reason I say that is because when you look over here, that's going to be the value that you probably look at for your A or your B, but that's not actually it. It's actually that entire fraction. And then same for this one. So it depends on what you're doing with this problem. If you're going to have to graph it like we're going to do, or find all the center, the vertices, the foci, and all that, you probably want to think of it like this. If the final answer is the equation, then you should leave it like this. Alright, so continuing on here. Now that I've got it in standard form, let's go ahead and find all the information that we're looking for. So the center will be the easiest thing to find now that's in standard form. It's negative 3 halves for the x value and positive 5 halves for the y value. The vertices, remember you need to look for the larger of the two numbers, so think about which one's the larger of the two numbers. It's actually that one. And if I take the square root of both numerator and denominator, I get the square root of 39 over 2. And again, you're going to have to approximate that a little bit. The square root of 36 is 6. That's between 6 and 7 somewhere. So between 6 and 7, let's just take a guesstimate and say that it's 3.5. You divide that by 2. Again, this is just for approximating reasons. Hopefully this would work out a little bit nicer. Looks like you're looking at something like 1.75-ish. So when I go to graph it, that's what I would do, is approximate like this. In terms of giving the vertices, I would actually use that number. So remember that number came under, or it was underneath y. So I need to add and subtract that number from the y value. So one vertice I'm going to give is negative 3 halves, comma, 5 halves plus square root of 39 over 2. And you can obviously say that it's 5 plus square root of 39 over 2. And then the other one would be negative 3 halves and 5 minus square root of 39 over 2. And so you can write it either way, whichever one you prefer. But you do need both of those. And then looking for the foci. For foci, remember your equation is c squared is equal to a squared minus b squared. So since this is my a squared, probably be a good idea to get a common denominator at some point. So I could multiply by 3 over 3. And you can multiply 39 by 3 out if you need to, or that's eventually going to give you 117 twelfths minus 39 twelfths. And then go ahead and take 117 minus 39 and you end up with 78 twelfths. And I can see that 78 and 12 have definitely a 2 in common, so I can sit there and reduce, and eventually I'm going to see that they have 6 in common, and this will simplify down to 13 over 2. Now that's c squared. That means c is going to equal the square root of 13 over 2, plus or minus. Remember, the foci move the same direction that the vertices do, so if you're going to list this out, they should be going up or down from the center. So the x value should stay the same. It should be negative 3 over 2, and then it's 5 plus square root of 13 over 2, and it's negative 3 over 2 and 5 minus square root of 13 over 2. When we go to graph them, we don't usually graph the vertices, so I don't have to approximate it like that. Alright, now in terms of the graphing, I'm just going to do this kind of guesstimation. Alright, my center is going to be negative 3 over 2, positive 5 over 2, so I'm going to do this very rough just to get through this problem. So negative 3 over 2, positive 5 over 2. I am going to have to approximate that when I take the square root of it, so you've got a calculator handy, go ahead and do that. If you don't have a calculator handy, you can do kind of like what we did up here, and you can calculate it out. So remember, you want to take the square root of that. That's going to give you 39 over 2, or if we actually plug it into our calculator so we know exactly what it is, square root of 39 divided by 2, it should be, I must have divided, oh, I think I already divided that by 2. Yeah, it should have been 6 point something and then divided by 2. I got ahead of myself. So I need to move approximately 3.12. So from here, remember that came under y, so I would go up 1, 2, 3, and then go a little over 3. Go down 1, 2, 3, and then a little over 3. Take the square root of 39/12. So I've got 39 divided by 12. Take the square root of that. 1.8. So then, because that's under x, you're going to go approximately 1.8 to the right, to the left, and then draw your ellipse. I probably should have spent a little more time drawing that ellipse. I kind of went through that quickly, but hopefully you have the idea. In terms of drawing the ellipse, it's simple enough. It's take the square root of that number, move right or left, the square root of that number up or down from the center, and then draw your oval shape. Hopefully that made sense to you. The bigger part of this problem is actually being able to take this and get it into standard form and then deal with it after that. Alright, problem number 3 is asking us to find the standard equation of an ellipse with, and then they give us some information. The information that we get on this one is that the vertices are negative 0, negative 5, 0, positive 5, and then it goes through the point 4, 2. So I kind of have to remember in my head what this thing looks like. Since the vertices, notice the y value is changing, that means that it's longer up and down, because the vertices are always on the major axis, we call them. So I know my graph looks something like that. Typically when I'm writing an equation, the first thing I do is try to find the center. And the center of your ellipse will always be the midpoint of the vertices. It would always be the midpoint of the foci, or if they gave you those 2 points, it'd always be the midpoint of those two. So the first thing that I'm going to look for this is I'm going to look for the center. And it looks like it's 0, 0. 0 if I add those divided by 2, 0 if I add those divided by 2. So I know it's longer up and down, so when I write my equation, it's x minus 0 quantity squared over something plus y minus 0 quantity squared over something equals 1. X minus 0 because of that number, y minus 0 because of that number. I don't know which one's which here for a second. Now, this is a vertice, so that means the distance from either one of these to the center is representing a. That means I know a is 5, or better yet, I know a squared is 25. So one of these numbers is 25. Pay attention, which one was changing? It was y. That means the 25 is here under the y term. And this is actually b squared. I got basically the entire equation just off of this. Now they probably gave me this for a reason, and that's going to help me figure out what b is. Kind of like we talked about it when we were working in the last section with parabolas and when you work with lines. They don't typically give you a random point on the graph unless they want you to find a given piece of information. You can take this x value, plug it in here, take that y value, plug it in here, and then b squared is the only thing that you'd be missing. So that's what they want you to do. So if I plug 4 in for x, I'm going to get 4 minus 0 quantity squared over b squared plus 2 minus 0 quantity squared, or you could just say 2 squared, over 25 is equal to 1. And now go ahead and try to solve. That's going to give you 16 over b squared plus 4 over 25 is equal to, I'm going to change that to 25 over 25 because I'm eventually going to have to subtract this over here. So I have 16 over b squared is equal to, if I subtract 4, I'm going to have 21 over 25. And now you're solving for b, so go ahead and cross multiply. You've got 16 times 25 is going to give you 400 is equal to 21b squared. Divide both sides by 21, and chances are that that's not going to go in there evenly, and if it doesn't, that's fine. It doesn't have to. My b squared value is that. It's 400 over 21. So when I write my answer, since it's an equation, I'm not going to put a fraction down here. I'm going to do this instead. I'm going to say it's x squared over, not going to write 400 over 21. I'm going to put the 21 up here, the 400 here, plus y squared over 25 is equal to 1. Again, since my equation is the final answer, I don't want to have a complex fraction if I can avoid it. All right. Let's take a look at our last one then. Our last problem is find the standard equation of the ellipse with the center at 3, -2. A is equal to 3c, and the foci are these 2 points. They gave me the center. That's wonderful. That means, remember, I usually say find the center first. That means I'm going to go ahead and plug this in immediately. Alright, so I've got this set up. Pretty much means I'm done with this. I've got these 2 things left. Now they gave me the foci, so I could obviously find the midpoint to find the center. Well, I already got the center, so I don't need that. So they actually didn't even have to tell me that. Notice something else. What exactly is changing here? It's not the y values, it's the x values that are changing. That means I know a squared is under x, b squared is under y. And something else. Notice the distance between the center and either of the foci. It's a distance of 2. That means c is equal to 2 because it's a focus that you're talking about. Well, if c is equal to 2, because neither one of those are c, look at this. Plug it in here. That means a is equal to 6. So now I know that a squared is equal to 36. The only thing I don't know is what is b squared. Well, it's an ellipse. I know c, I know a or b, so chances are I should be using that formula. So c squared, which would be 4, is going to equal a squared, which would be 36, minus b squared. Go ahead and subtract 36. I get negative 32 is equal to negative b squared. Double negative, so I can cancel those. I don't want, chances are your instinct's telling you to take the square root. I actually don't need to. I need to know what b squared is. 32 is my b squared, and there's my equation. So sometimes these take a little bit of practice, but my recommendation is always find the center first. If they don't outright give it to you, that means they're giving you both foci, both vertices, or both quote-unquote other vertices. So find the center, plug that in right away, look at the foci or the vertices and pay attention to what's changing, because that'll tell you whether a squared is under x or y, and then kind of go from there. Alright, that is homework help for 10.3. Let me know if you need any extra help.